A player throws a ball vertically upwards. It reaches a maximum height of 20 meters and returns to his hand. For how much time it remained in the air? The options given are 2 seconds, 3 seconds, 4 seconds and 5 seconds. For this problem, let us find out the time taken for the ball to reach from the point of projection to a maximum height, and the time that it comes back again would be equal, hence we can divide it, multiply it by 2. So to find out the time for reaching the maximum height, we can use the kinematic equation v square is equals to u square plus 2as. Since at maximum height the velocity would be 0, u square plus 2 times minus 10 into 20. Therefore u square is equals to 400 and u is equals to 20 meters per second. Let us use this value of u in the kinematic equation. V is equals to u plus 80. Therefore 0 is equals to 20 minus 10 times t. Therefore t is equal to 2 seconds. This 2 seconds is time required to go up to the maximum height. So to come back again to the original position, we need to multiply it by 2, that is 4 seconds. Hence option C is the correct answer. Two bodies, A of mass 1 kg and B of mass 3 kg, are dropped from heights of 16 meters and 25 meters respectively. The ratio of the times by them to reach the ground is, the four options given are 5:4, 12:5, 5:12 and 4:5. So for a freely falling body, the h is equals to ut plus half gt square. However, since it is freely falling, the initial velocity is equal to 0. Therefore, h is equals to half of gt square. So for h1 and h2, note that since the mass term isn't included in this, the values of mass for kinematic equations, the time taken doesn't really depend upon the mass. So the value or the data of mass given is just a redundant data. So h1 by h2 can be written as half g t1 square and half g t2 square, which is equals to t1 square by t2 square. So t1 by t2 can be written as root of h1 by h2, which is a root of 16 by 25, which is 4 by 5. Hence option D is the correct answer. A ball is thrown vertically upwards. It has a speed of 10 meters per second when it has reached one half of its maximum height. How high does the ball rise? The value of g is given as 10 meter per second square. The four options are 10 meters, 5 meters, 15 meters and 20 meters. So in order to solve this sum, let us draw a figure. The ball is projected from point A to C and the total height, let's say it is at h. So when it reaches half height, that is h by 2, it is at point B and it has reached a velocity of 10 meters per second. So for this, using the kinematic equation v square is equals to u square plus 2as, we get at point C, at C velocity is equals to 0 and at B velocity is equals to, or u is equals to 10 meters per second for the upper half. Therefore 0 is equals to 10 square plus 2 times minus of 10, that is the acceleration due to gravity, into h by 2, that is the displacement. Therefore 10h is equals to 100. Therefore h is equals to 10 meters. Hence option A is the correct answer. A ball is thrown upwards with certain velocity. At the same instant, another ball is released from a height of 60 meters. They meet at a height of 15 meters. What is the initial velocity of the first ball? Take g is equal to 10 meters per second square. So let A be the point from where the ball is released, and B be the initial ball. So both of these meet at a height of 15 meters and A is at a height of 60 meters. So the freely falling ball has traveled a distance of 45 meters before reaching point C. So let the two balls meet at point C. So the distance traveled by the ball C, the freely falling ball till point C is 45 meters. So H is equals to half GT square. So let's find out the time that it takes to reach the point C. So 45 equals half into 10 t square. For t is equals to 3 seconds. Now that the value of t is equal to 3 seconds, both the balls meet each other after a time of t is equal to 3 seconds. So the ball which is projected from point B, let us find out the distance that it travels in that time. Let us find out the initial value using the time t is equal to 3 seconds. Therefore, 15 is equals to u into 3 plus half minus 10 into 9. Therefore, u comes out to be 20 meters per second. Hence, okay, and u is equal to 20 meters per second. Therefore, option number A, 20 meter per second, is the right answer. A particle is projected vertically upwards with a velocity of 40 meters per second. What are the distance and displacement in 6 seconds? Take g is 10 meter per second square. The options given are 60 meters and 80 meters, 20 meters, 60 meters, 60 meter, 100 meter, 100 meters and 120 meters. Let the ball or the particle be projected from point A and let B be the maximum height reached. So it is projected with the velocity of 40 meters per second. So the time taken to reach the maximum height is given by u by g, which is 40 by 10 is equal to 4 seconds. And the maximum height, the height AB, is given by u square by 2g, which is equals to 40 square upon 2 into 10, which is nothing but 80 meters. So the maximum height is 80 meters. Now, after 4 seconds, the ball reaches the point B and again starts to drop for the remaining 2 seconds out of the 6 seconds. So in the remaining 2 seconds, the ball takes a free fall for a time of 2 seconds, and the distance covered would be given by half gt square, which is nothing but half into 10 into t square, that is 4, is 20 meters. So the total distance is 80 and it falls back to a distance through 20 meters. So the displacement over here is 80 minus 20, 60 meters, and the distance traveled is 80 plus 20, that is 100 meters. Hence option C is the correct answer. The water drops fall at a regular intervals from a tap 5 meters above the ground. The third drop is leaving the tap at an instant when the first drop touches the ground. How far above the ground is the second drop at that instant? The options given are 5 meters, 1.25 meters, 3.75 meters, and 2.5 meters. Let us assume that this is a tap, the second drop, and this is the first drop, and here would be the third drop. So it is at a 5 meter height from the ground. Now let t be the time interval between the falling of two drops. So for the first drop, s is equal to ut plus half at square, but u is equals to 0 and a is equal to g, and t would be 2 times t. T would be equal to 2 times t, since two drops have The second drop has already left, so the time that would be taken would be for 2 drops, so that the first drop reaches the ground. Therefore, solving for this, 5 is equals to half into 10 into 2t square. Therefore, 4t square is equals to 1. Therefore, t square equals 1 by 4, or t is equals to half second. So, half a second of time interval between the 2 drops, and in this time the second drop will cover a distance of half gt square, which is nothing but half into 10 into half square, that is 1 by 4. So 5 by 4 meters. So the height of the second drop from the ground would basically be 5 minus 5 by 4, which is equals to 15 by 4 meters, which can be simplified as 3.75 meters. Hence option C is the correct answer. A man can safely jump from a height of 2 meters on the surface of the earth. What would be the safe height for jumping on a planet where the value of g is 1.96? The options given are 4 meters, 6 meters, 10 meters and 2 by 3 meters. So basically in order to find out the safe height, what we need to know is the terminal velocity or the final velocity of the man when he reaches the ground. Let it be at for planet Earth, let the safe velocity be v, and for the other planet, unknown planet, let it be a v dash. Now v should be equal to v dash, so that a safe limit, considering safe limit, is reached. Using the kinematic equation, v square is equal to u square plus 2gs, and since the man is dropping, u would be equal to 0. So v square is equal to 2gh, and similarly for the planet it would be v dash square, which equals 2 times g dash into h dash. But since v and v dash should be equal, therefore 2gh is equal to 2g dash h dash. Therefore h dash is equals to gh upon g dash, which is equals to 9.8 into 2 upon 1.96. So the answer is 10 meters. Hence option C is the correct answer. A man throws a large number of balls vertically upwards in quick succession in such a way that when the first ball reaches the maximum height of 5 meters, the second ball is thrown upwards. What is the time required to throw 50 balls? The options given are 25 seconds, 50 seconds, 75 seconds and 100 seconds. So when the first ball reaches the maximum height, its velocity becomes 0. So just let's find the initial velocity for reaching a height of 5 meters. So v square is equal to u square minus 2g into h. V is equal to 0. Therefore u square is equals to 2 times g is 10 into h is 5. So that is 100. So u is equals to 10 meters per second. So the balls are projected at a speed of 10 meters per second, and the time up for which the balls reaches the maximum height is given by u by g, which is equals to 10 by, let's take acceleration as 10, so 1 second. So balls are thrown in after a time period of 1 second. Hence for 50 balls the time period would be 50 seconds. Option B is the correct answer. There is a leakage in the ceiling of a room of height 4 meters. Drops of water fall regularly from the ceiling in such a way that when the third drop leaves the ceiling, the first drop touches the marble floor. What is the position of the second drop when the third drop just leaves the ceiling? The options given are midway between the ceiling and the floor, at a height of 1 meter from the floor, at a height of 3 meters from the floor, and at a distance of 2.5 meters from the ceiling. Let us assume that t is the time interval between falling of 2 drops. So for the first drop, when the first drop leaves and reaches the floor, two drops have already left. So therefore the time taken for the first drop to reach the floor is nothing but 2t. And since initial velocity is 0, therefore the displacement s is equals to half g into 2t square. Therefore 4 is equals to half g t square into 4. Therefore gt square is equals to 2. Let us keep this value. Now for the second drop, the displacement would be half g t square. Now let's just substitute this value as 2. Therefore s dash is equals to 1 meter. Therefore the second drop is at a distance of 1 meter from the roof, and which means it is at a height of 3 meters from the floor. Hence option C is the correct answer. A stone is projected with a speed v at an angle theta with the horizontal. What is that angle between the direction of its velocity and acceleration at the highest point in the trajectory? The options given are 0 degrees, 30 degrees, 60 degrees and 90 degrees. For an object that is projected at the highest point, the vertical component of velocity becomes 0 and hence only horizontal component of velocity is remaining. And the acceleration is purely due to gravity. So as we can see from the figure, they both are perpendicular to each other, and hence option D is the correct answer. A stone is projected at an angle of 30 degrees with the horizontal. The vertical component of its velocity is 80 meters per second. What is the horizontal component of its initial velocity? For a stone that is projected at an angle theta, the horizontal component is given by v cos theta and the vertical component is given by v sin theta. So the vertical component of velocity is given as 80, which is equal to v sin theta. Therefore v is equals to 80 divided by sin theta, that is sin 30. So 80 upon sin 30 is half. Therefore v is equals to 160 meters per second. Now the horizontal component is given by v cos theta. Therefore horizontal component is equals to 160 into cos 30, which is equal to 160 into root 3 upon 2 is equals to 80 root 3. Hence option B is the correct answer. A body is projected obliquely with maximum kinetic energy K. What is its maximum potential energy in its path? The options given are k sin theta, k cos theta, k tan theta and k sin square theta. For a body which is projected along a parabolic path, the maximum potential energy is at the highest point h and maximum kinetic energy is at the initial point. So kinetic energy is half mv square, whereas at the maximum highest point the vertical component of velocity becomes 0, which means it has a least kinetic energy and maximum potential energy. So maximum potential energy is at a point h, which is equal given by mgh. So mg, the height of projection, is given by v square sin square theta upon 2g. So clubbing mg v square and 2g, we get mv square by 2 into sin square theta. mv square by 2 is nothing but kinetic energy k sin square theta. Hence option D is the correct answer. A stone is projected obliquely in the air with a velocity u bar equals 25 I cap plus 20 j cap meters per second. What is its displacement after 2 seconds? In order to find this, the given initial velocity is given as 25 I cap plus 20 j cap. The horizontal component of velocity Vx is nothing but 25 meters per second. Since the horizontal component of velocity for a projected body always remains constant, therefore after time t is equals to 2 seconds, the displacement in the horizontal direction is given by x is equals to Vx into t, that is 25 into 2, which is 50 meters. And in the vertical direction, the vertical component of velocity is given as Vy is equal to 20 meters per second. So after a time period of 2 seconds, the displacement in the y direction is given by Vy into t minus half gt square. Substituting the value of t as 2, we get y is equals to 40 minus 19.6, which is equal to 20.4 meters. Therefore, displacement after 2 seconds can be written in the vector form as 50i plus 20.4 j. Hence, option B is the correct answer. A hose pipe lying on the ground shoots a stream of water at angle of 60 degree with the horizontal with a velocity of 20 meters per second. The height at which the water strikes a wall at a distance of 10 meters is, the options given are 8.5 meters, 12.32 meters, 15.5 meters and 20.8 meters. So when the water is projected at an angle of 60 degrees, there is a wall at a distance of 10 meters. Now, for a projection, the horizontal component of velocity always remains constant. Hence, Vh, or velocity of the horizontal component, is given by V cos theta, which is equals to 20 cos of 60, which is equals to 10 meters per second. So the time taken by the water to reach a distance of 10 to reach a wall which is at a distance of 10 meters is given by distance on speed, which is equal to 1 second. So it takes 1 second to reach a wall of 10 meters. So we'll find out the vertical displacement in the y direction during 1 second. So y is equal to v sine theta times t minus half g t square. Substituting the values, we get 20 sine 60 into 1 minus half into 10 to 1 square, which is equals to 20 root 3 by 2 minus 5 and 10 root 3 minus 5. Root 3 is approximately 1.732. Therefore, 17.32 minus 5 is approximately 12.32. Hence, option B is the correct answer. Four balls A, B, C, D are projected with the same speed, making an angle of 10 degrees, 30 degrees, 60 degrees and 45 degrees with the horizontal. Which ball will strike the ball at the farthest point? The options given are D, A, B or C. For an object which is projected the same velocity but different heights or different angles, the maximum range is reached when the angle of projection is 45 degree. So in order that the farthest point is reached, the ball should be projected at an angle of 45 degree, and 45 degrees projected for angle for the ball D. Hence, option A is the correct answer. The maximum horizontal range of a projectile is 980 meters. What is its initial speed? The maximum range of horizontal of a projectile is given by the formula h is equals to u square upon g. Make a note that when theta is equal to 45 degree, the horizontal range is maximum. Therefore, h is equal to u square by g. So 980 is equals to u square upon, let's take it as 10. Therefore, u square is equals to, or let's take it as 9.8 for simplification. U square is equals to 9.8 into 980, which can be written as 9.8, which can be written as 98 into 98. Therefore, U is equals to 98 meters per second. Hence, option B is the correct answer. A missile is to be hit on an enemy target 16 kilometers away. What must be the initial velocity of the missile? The options given are 300 meters per second, 350 meters per second, 400 meters per second, and 450 meters per second. In order to hit missiles which are far away, the angle of projection usually is taken as 45 degrees. So, for 45 degrees, the maximum horizontal range R is given by u square upon g. Therefore, u square is equals to r times g, which is equals to 16 kilometers can be written as 16,000 meters into g is 10. So 16. So u is equals to root of 16,000, which is nothing but 400 meters per second. Hence, option C is the correct answer. A stone is projected obliquely in air with velocity v. It is found that its horizontal range r is n times the maximum height h reached by the stone. What is the angle of projection? The answers options are sine inverse of n by 4, tan inverse of 4 by n, tan inverse of n by 4, and cos inverse of 4 by n. It is given that r is equals to n times h. Therefore, formula for r is v square sine 2 theta upon g and equals to n times v square sine square theta upon 2g. Equating these two, therefore 2 times sine theta cos theta is equals to n times sine theta square upon 2. So n sine theta is equal to 4 times cos theta. Therefore, n by 4 is equals to, rather, tan theta is equals to 4 by n. Therefore, theta equals tan inverse of 4 by n. Hence, option B is the correct answer. What is the maximum height reached by a ball if it is projected with an initial velocity 4i plus 3j? The options given are 1 meters, half meter, 0.25 meters, and 9 by 20 meters. Now V bar is given as 4i plus 3j. Let us draw vector triangle for this. So the horizontal component is 4, vertical component is 3. So by Pythagoras theorem, the hypotenuse would be 5 units and projection is theta. So horizontal component is 4, vertical component is 3. Therefore, V would be 5 meters per second. Also, we can see that sine theta is equals to 3 by 5 and V sine theta is equals to 5 into 3 by 5, which is nothing but equal to 3. Maximum height, the formula for maximum height is given by v square sine square theta upon 2g, which is nothing but v sine theta square upon 2g. V sine theta has a value of 3, so 3 square upon 2 into g taken as 10 becomes 9 by 20 meters. Hence, option D is the correct answer. A bullet is fired from a cannon with a velocity of 500 meters per second. If the angle of projection is 15 degree and acceleration due to gravity g is equals to 10 meters per second square, then the horizontal range is. The formula for horizontal range is given by u square sine 2 theta upon g. So substituting the values, we get 500 into 500 into sine of 2 theta, that is 2 into 50, 30, divided by g, take it as 10. So r is equals to 500 into 50 into half, since 10, which is equals to 12.5 into 10 raised to 3 meters. Hence option B is the correct answer. A ball is projected with the same velocity but different angles with the horizontal, for which angle of projection the height reached to its maximum. The formula for maximum height is given by v square sine square theta upon 2g. As we can see, h is proportional to v square and theta square. Since the velocities or initial velocities are the same, so h here is proportional to theta. Hence, as angle increases, the maximum height will also increase. Therefore, option D, 80 degrees, is the correct answer. From the top of a tower of height 40 meters, a ball is projected with a speed of 20 meters per second at an elevation of 30 degrees. The ratio of total time taken by the ball to hit the ground to its time of flight is, the options given are 2:1, 3:1, 3:2 and 4:1. Here the initial velocity is given as 20 meters per second and the angle of projection is given as 30 degrees. The formula for time of flight t is equals to 2u sine theta upon g, which is 2 times 20 sine 30 upon g can be taken as 10, is equals to 2 seconds. Now, if t is the total time taken by the ball to hit the ground, then using the relation s is equals to ut plus half at square, where h is equals to 40 meters and u is equals to v sine theta and a can be written as g. We get 40 is equals to minus of u sine theta times t plus half into 10 to t square minus 20 sine theta is half, sine 30 is half to t plus 5t square, which is equals to 5t square minus 10t, and this is equals to 40. Therefore 5t square minus 10t minus 40 is equals to 0. So t square minus 2t plus minus 8 is equals to 0. Solving this quadratic equation, we get t minus 4 t plus 2 is equals to 0. Since t cannot be minus 2, t should be equal to 4. Therefore t by t is equals to 4 by 2, which is equals to 2:1. Hence option A is the correct answer. A projectile can have the same range r for two angles of projection if t1 and t2 be the time of flight in the two cases. Then the product of the two times of flights is proportional to r 1 by r, 1 by r square and r square. For two angles, if this for two angles, if the horizontal range is the same, it means that the angles are complementary to each other. So if one angle is theta, the other angle would be 90 minus theta. Hence, let's t1 is the time for the first. So 2e sine theta upon g, and t2 be the sign for the time for the second angle. So 2v sine of 90 minus theta upon g. Sine 90 minus theta can be written as cos theta upon g. So the product of T1 into T2 is equals to 4v square sine theta cos theta upon g square. So this can be written as 2v square sine 2 theta upon g square. But horizontal range R is given as v square sine 2 theta upon g. So therefore, substituting these values over here, T1 into T2 is equals to 2R upon G. As we can see, T1 and T2 is proportional to R, hence option A is the correct answer. A plane flying horizontally at 98 meters per second releases an object which hits the ground in 10 seconds. What is the angle made by the velocity of the object with the horizontal at the time of hitting the ground? The options given are 30 degrees, 45 degrees, 60 degrees and 75 degrees. Let us assume that a plane has dropped a package. So it goes and hits the ground. The package has an horizontal velocity component, as the horizontal component of velocity is 98 meters per second, since that is what the speed of the plane was. So velocity in the x direction. Now for y direction velocity, since it falls, Vy is equals to u plus gt. Since the vertical component of velocity, initial velocity of the vertical component is 0, therefore Vy is equals to g times t. So for Vy is equals to g 9.8 into time t, that is 10 seconds. Therefore the angle that is made by the velocity component theta is given as tan theta is equals to Vy upon Vx, which is nothing but 99.8 into 10 upon 98 is equals to 1. Hence theta equals tan inverse of 1, which is nothing but 45 degrees. Hence option B is the correct answer. Two trains, each 50 meters long, are traveling in the opposite direction with velocities of 10 meters per second and 15 meters per second. In what time will they cross each other? The options given are 2 seconds, 4 seconds, 2 root 3 seconds and 4 root 3 seconds. Now since the trains are moving in the opposite directions, therefore the total distance that the trains have to cover is the addition of each length, which is equals to 100 meters. Also, since they are moving in the opposite direction, their velocities add up, hence relative velocity is equals to 10 plus 15, which is equals to 25 meters per second. Therefore, time of crossing is given as distance upon velocity, which is nothing but 100 upon 25, which is equal to 4 seconds. Hence, option B is the correct answer. A ball A is thrown up vertically with a speed u, and at the same instant another ball B is released from a height h, where h may be smaller than or equal to the maximum height reached by A. Then the speed of A relative to B at any time t is given by u minus gt, 2u, u and gt. For upward motion of the ball A, since it is moving in the upward direction, at any time instant t, the velocity of A is given as u minus gt, and for ball B, at any instant in time d, since for falling down, velocity of ball B is given by Vb is equals to Gt. Therefore, since the balls are always either moving upward and the ball A is moving upward and the ball B is moving downwards, they are constantly in the opposite directions. Hence, the relative velocity of A with respect to B is an addition of both. So, which is Va minus Vb, which is nothing but U minus Gt, and Vb is minus Gt. This minus sign comes because the ball B is moving in the downward direction. Therefore, U minus Gt plus Gt. Therefore, answer is option number C, which is U. A train of length 200 meters traveling at 30 meters per second overtakes another train of length 300 meters traveling at 20 meters per second in the same direction. What is the time taken by the first train to pass the second train? The options are 30 seconds, 40 seconds, 50 seconds, and 60 seconds. Now, the relative speed of the trains. Since they are moving in the same direction, the relative velocities are subtracted. So relative velocity is basically 10 meters per second. When the first train crosses the second train, the total distance which it has to cover is the addition of both the lengths, that is 300 meters and 200 meters. Therefore, distance that the train has to travel is nothing but 500 meters. So the time to travel a distance of 500 meters with a relative velocity of 10 meters per second is given 500 by 10, that is equal to 50 seconds. Hence, option C is the correct answer. The water in a 30-meter wide canal is flowing at a rate of 20 meters per minute. A man who can swim at the rate of 25 meters per minute in still water wants to cross the canal perpendicular to the flow. What is the time taken by him to cross the canal? The options given are 1 meters, 1 minute, 1.5 minute, 2 minutes, and 2.5 minutes. In order to cross the canal in a perpendicular direction, the man would have to let the water be flowing in this direction. So the man would have to go in a kind of a reverse opposite to the flow of stream, so that his velocity and the perpendicular velocity can compensate each other, and he would cross the stream or the canal in a perpendicular direction. So 30 meters is the width of the canal and his speed is 25 meters per minute, whereas the flow of water is 20 meters per minute. So the resultant velocity V is given as root of 25 square minus 20 square, which is equals to root of 625 minus 400, which is equal to root of 225, which is equals to 15 meters per minute. Therefore, resultantly the man is traveling at a speed of 15 meters per minute. So in order to cover a distance of 30 meters, the time taken would be 30 divided by 15, which is equals to 2 minutes. Hence, option C is the correct answer. A boat covers a given distance in 6 hours moving downstream. It covers the same distance in 10 hours moving upstream. The time in hours it takes to cover the same distance in still water is. Now let Vb be the velocity of the boat and Vr be the speed of the river. Now make a note that Vb should be greater than Vr so that the boat would move in the opposite direction. Now when they are moving in the same direction, the relative velocities would be Vb minus Vr, and the time taken in the same direction is pardon me, the when they are moving the same direction, the velocities would add up, and the relative velocity would be Vb plus Vr, and the time taken is 6 hours. Whereas when they are moving in the opposite direction, the relative velocity would be Vb minus Vr, and the time taken is 10 hours, and both of these correspond to a distance d. Therefore, Vb plus Vr into 6 is equals to Vb minus Vr into 10. Therefore, 6 Vb plus 6 Vr is equals to 10 Vb minus 10 Vr. Therefore, 16 Vr is equals to 4 times Vb. Therefore, Vr is equals to Vb by 4. Therefore, substituting the value of Vr in this, we get Vb plus Vb by 4 times 6 is equals to d. Therefore, d is equals to 5 by 4 Vb into 6 is equals to 7.5 Vb into h or hours. Therefore, time t, to carry out a distance of t in still water is given by d divided by Vb, which is equals to 7.5 Vb into h on Vb. Therefore, t is equals to 7.5 hours. Hence, option B is the correct answer. An aeroplane is flying horizontally with a velocity of 600 kilometers per hour, and it is at a height of 1960 meters. When it is vertically at a point A on the ground, a bomb is released from it. A bomb strikes the ground at point B. The distance AB is, the options given are 33 kilometers, 1200 meters, 3.3 kilometers, and 0.33 kilometers. So in order to solve this, assume that this is a plane which is moving at 600 kilometers per hour, and at this point the package or the bomb is dropped over the point A. It will travel and reach the point B. So the horizontal velocity of the package when it is released from the plane is 600 kilometers per hour, which can be written as 600 into 5 by 18. That is nothing but 1 by 6 kilometers per second. Let us just make it into kilometers per second. So it will be just divided by 3600. Now the speed of the bomb is 1 by 6 kilometers per second. The horizontal distance that the bomb travels, or the vertical distance, is given by half gt square. Since the bomb is free falling, therefore a height of 1960 meters to half 9.8 t square. Therefore the time which it takes 400 seconds. At time t is equal to 20 seconds, the velocity would be 600 kilometers per second, 3600, 1 by 6 kilometers per second, as we got the same thing here. So the distance traveled would be given by S is equals to U into T. That is nothing but 1 by 6 into, here the T square is 400, so T would come as 20 seconds, and the time T would be replaced here as 20 seconds, which comes out to be 3.33 kilometers. Hence option C is the correct answer.